Welcome to Compose, a software development podcast featuring the Rust programming language and how it interacts with the world. This episode features interoperability with C++ and how that might progress over the years and even decades ahead. To talk us through it all is David Sankel from Adobe. David is an invited speaker at this year's RustForge conference. RustForge itself is happening in Wellington, New Zealand, and you're still very welcome to come. For those of you who would even like a discount, try visiting rustforgeconf.com/compose.
I guess I am at heart a computer nerd, so I'm sitting here and in front of me is like these little microprocessors, right, that I'm just programming for fun. But I guess who I am probably of interest to this community, I am a principal scientist at Adobe, and I run Adobe Software Technology Lab. And that is a team which is focused on what is going to be happening in the next 10 years with software development. And we're very much, our heads are in that space, and we have to figure out how we're going to have Adobe align with that future, and also how can we help steer the industry so that it can better support what's going to be happening going forward. So that's my day job, and I'm also very involved in the C++ Standardization Committee, and now more recently involved in Rust, and specifically Rust Interop, and doing that at Adobe. So
I feel like for many people, that kind of sounds like a bit of a dream job. Look, basically...
It is a dream job. Let me tell you a story about that, because it's funny. So Sean Parent, who is known in the C community, was running this team, and he invited me to join it. And he said that he sold it pretty much as a dream job. And it was like, this is my dream job. And I got there and he convinced me to swap positions with him. So I would run the team and he would have my dream job. And he managed that. And I was like, I see what you did there. You created the dream job, and then you took it for yourself and made me the manager of the team, which is slightly less than the dream job of actually being on the team. But yeah, that's how that happened.
It takes a certain amount of humility humility is possibly the wrong word, but to be really and supportive of others and actually sharing in the facilitation of others' success. And so being a manager is, I actually think that's a better paid, let's say, but also a slightly underrated career track. People look down on management in some ways as no longer being technical or something. But I think that it is in some sense gracious that you're able to give that up and just to enable, let's say, multiply your own thoughts by X. So that's a good thing too, in my opinion.
Oh yeah, definitely. And I say this mostly in jest, and as lead of Software Technology Lab, I'm still very much involved in doing the actual technology, because it's a very small team. There's only 4 people in the team. So yeah, I get to stay hands-on and do all the crap work that Sean was doing before. So I'm happy to have him spend his time not doing that crap work and take that on.
Yeah, look, some people have to be professional meeting goers. Yes. Anyway, we're going to need the actual chip number or like the part number of the microcontroller that you're playing with at some point, because I'm sure that
this is the STM32C011J4M6. There you go.
For anyone that is coming to RustForge in, I guess it's 6 weeks' time from this recording, Espressif is actually donating several dozen microcontrollers. We haven't actually announced this, so this is the big reveal, but it should be the case. I hope we're getting at least one for everyone that turns up. Yeah, no, so there's a segue in there as well, but that's really great. And
I'm going to be first in line for that thing.
Awesome. The next thing is, you're looking at the next 10 years of programming, let's say, in a very broad way. Rust is part of that story.
Yes.
When do you think large companies such as Adobe, or there are many billion-dollar companies, let's say, when do you think large enterprises would have really started to notice Rust?
I think it's already started, and I can tell you how we got into it from the beginning. Back in 2024, they created this memory safety tiger team, okay, and that included reps from security, the software technology lab, developer experience, and legal reps. And the reason that it was created is because there was all this discussion of legislation related to memory safety. and they wanted to figure out like, what is this? What are we going to do about it? And you had the NSA, you had the White House even chiming in on this stuff. And at one point there was even a bill, I think it was like a defense spending bill, like a typical bill that when it was in the House of Representatives, the Congress, they had like creating a memory safety plan for the Department of Defense. And this little line got removed when it went in the Senate. So it didn't actually end up in the final thing that got approved. But the fact that it was there was like huge. And so this team got together and we're like, okay, what do we need to do about this? And we investigated and we looked at what was going on with like the published data that people were having. So you look at the numbers. It's okay, the number of exploits in software that are due to memory safety versus all the other exploits was like 70%. And you look at Microsoft's numbers, it's 70%. You look at Google's numbers, it's 70%. And then we looked internally and it's also right around that number too. So there's like something to this. And the idea that you can switch your technology and get rid of 70% of your memory safety vulnerabilities, like that was a big deal.
My recollection of those papers as well, it's not just 70% of bugs, let's say, but 70% of severe and critical CVEs. So it's like these are the majority of the worst cases of security problems. And yeah, and so this was so I guess it sounds like there were probably engineers thinking, for the last multiple decades, and I'd be interested, and C++ has had this in front of mind for a long time. How do we deal with buffer overflows and how do we deal with memory safety in a way that is strongly backwards compatible, which I suppose is the C++ mantra, really. And then we have this new programming language, which somehow is able to offer memory safety without imposing garbage collection or some sort of other form of runtime checking to be able to allow things to work. But it was really it sounds like it was really the fact that it had started to introduce legal risk that really started to motivate internal people to say, okay, we're going to fund something, at least some sort of discussion to make a decision on how we're going to proceed.
For us, like the legal risk was why upper level management got involved. And they said, can you investigate this? When we investigated it, it wasn't like, oh, yes, there is significant legal risk. We're looking at these laws that are coming out. It was more, what about our customers?
Actually,
like, we want our customers to use safe software. That's totally in our interest. And that's actually our driving motivation in this group is we want to produce the most safe software that we can for our consumers. You imagine if somebody comes out with a PDF that exploits your computer. How many people are using Acrobat? We look, there's more people have Acrobat Reader on their computer than people that use Firefox, like in total. So it's a huge swath. And if you take state actors or whatever, if you want to get into people's computers, you're going to try to get in the software that most people use. And we're definitely in that space.
Yeah, so and PDF is not a simple format to protect against. Really, I don't mean to cast any shade, but we've got multiple programming language interpreters. There's at least a JavaScript runtime, plus there's two other languages, right? Its own little macro language, as well as PostScript in there too, I think. But
it's extremely complicated, yes. And the fact that it can embed a JPEG or something like that. And there's
because now every single codec that you support also has decompression, and you've also got essentially like these baby interpreters for file formats, which are also exploitable, as browser vendors have discovered multiple times. Yeah, and okay, so that would be good to be able to defend against these kind of poisoned PDFs, which of course that's a horrifically big vector of problems, because of course you're going to double click the PDF and open it when you get it via email.
Yeah. But like on the flip side, so from a software technology lab perspective, before memory safety became something that everybody knew about and was talking about, we were already trying to figure out what's going to be the future of programming languages. Is it going to be C++? Is it going to be one of these other languages? And from our perspective on that team, the memory safety wasn't actually the most interesting thing about Rust as a language to move to. It's just flatly better tech for most applications, even if you didn't have the memory safety aspect. If you look at like enums, pattern matching, traits, like all the procedurally macro-driven libraries that are in there. And there's a lot of stuff like that just made it interesting. Hey, we want people to develop in these languages because they're going to be more productive, and the code they're writing is going to be more maintainable. And it's going to be easier to hire developers because it's easier to get them to learn the language and be able to work on it. These are like other big drivers that I think stand on their own without even looking at the memory safety.
Yeah, I have been in very similar discussions where people look and say, oh gosh, we've got this huge problem, and that's the motivating factor. But it turns out that Rust is also a very good programming language, and it has lots of nice things. We have iterators, for example, that compose and just chain together quite nicely and also get optimized quite well. And then from the point of view of comparing Rust to, let's say, a Java, C#, or even a Python or something, and my background is primarily in web services and so forth, but we would also say that we could probably reduce memory by, I don't know, 90%. And the cost of running an application, suddenly we only require 80 megabytes of RAM at steady state. So we don't need giant instances with lots and lots of heap. So actually, we are able to produce applications that run faster, serve users quicker, and are also more secure. And yeah, and by the way, yeah, also Rust is quite a nice programming language. And now we've got this other problem that you're advocating for a programming language, or at least saying to the rest of the company, by the way, the grass is greener over there. But at some point, the immune system of the organization responds to you and says, we have a lot of other languages. We don't want to add another one to the mix.
Yep. And we definitely see those really healthy immune system responses, just like anywhere else. And I think that a lot of what's been useful to dispel some of the concerns that people have has been the great data that's been put out there. So one of the concerns someone might say is, oh, but Rust is really complex, right? It's a hard language to learn. We can't wait for people to spend 3 years learning this language to be able to be productive in it. And then for that, point out to the Google study that came out where it was like, I think it was after 3 months of development in Rust from someone that has no experience at the beginning, 2/3 out of people felt like they were very confident and productive in this language, right? So that you just point to the data. It's like you can go with your anecdotal feeling about it, but why do that when we can look at the data when there's been like good studies that have been put out there? And so a lot of things like this is just like getting the right information in front of people so that they don't have to go based on their gut. They can go based on something more solid and tangible. I think that's been extremely helpful.
I've never worked at Google, but I've got lots of friends there. And one of the things that makes me believe that research is that Google has full control over its build system and the developer experience as well. Mm-hmm. One of the things that I would really like to pick up on was another claim around hiring, because I've heard that hiring Rust developers is really hard.
So one thing I can say is that hiring C++ developers is incredibly hard. And for us, I can't share with you the data, but I can say that it is astronomically harder than hiring for any other language that we have, especially in the US. And that is another one of the motivations as to why we're looking at other languages that we can bring on developers, because if you got a new project and you can't staff it, then but you can change the language and staff it better, you may just change the language based on that alone. And so we looked a lot at the adoption of Rust in the wider community. And we looked at, again, we're like, let's see the data. And so there was a Stack Overflow survey that came out. I think if you look at the 2024 Stack Overflow survey, we crunched the data and we looked at the number of developers that are C++, and we looked at what portion of C++ developers right now are also Rust developers. And it was 20%. Kind of blew our mind. 20% of all C++ developers are also developing Rust. And this is like, the question was asked, like, have you programmed this seriously, like in the past year? And that's huge. But maybe that's Stack Overflow could be weird. Only weird people fill out that survey. But we also looked at the data from GitHub, and for every 5 C+ PRs on GitHub, there's 1 Rust PR. So again, like a similar kind of number. There's just a lot of people programming Rust, it turns out. And I've asked this question at conferences that I give talks at. How many of you are programming Rust as well? It's like similar number everywhere. It seems to be right around 20%. And that's changed from 16% like 5 years ago. It's just been like a drastic increase in the number of Rust developers. So I do not have concerns of hiring Rust developers. If you say you got a Rust position, you got like a bunch of people going wild because they would love to do Rust full time, just because you just feel better programming in that language. Like going from Rust back to C++ kind of hurts a little bit. You die a little bit inside when you come back to that C++ project. And so there's just enough enthusiasm for it. That isn't a concern, although people raise it, but look at the data again, it really isn't in actuality a concern.
Yeah, there is a lot of, I forget the term, but there's a particular psychological bias where we are afraid of change because of its loss aversion, I think, where people are hesitant to take on change or risk even when the outcome is likely to be positive. The other thing that I have found people resisting is this idea that Rust is as good as it sounds. People make this claim around, oh, it's a really lovely programming language to use. We finally have a genuine type system. Null pointers don't really exist in the language. And it's like, where's the catch? And I guess the next thing to chat about would be so Photoshop sounds like there are changes happening. What's happening?
Yeah, we are at the stage to where we've done a couple of pilot projects of where we're doing Rust inside of Photoshop, and we're seeing how that's going. Like what exactly happened. So we took a team, we said, okay, we have a project here. We want you to do this in Rust for Photoshop. What is your experience of that? And it came out what you would expect. The people who used the language loved it. They're reticent to go back to like a C++ kind of thing. After that, they saw the productivity gains, especially being able to use cargo. I mean, one of the most powerful experiences you can have is when you're like, I think it'd be nice if we had a JavaScript interpreter in this program. And you just add a JavaScript interpreter with like one line in your cargo thing. Like coming from a C++ background, that is black magic. That should not be that easy.
Right? Who doesn't love tinkering with CMake or whichever build systems that you feel like creating today? Why even have one build system when you could have 4 in your project or something? I don't mean to be too rude, but Rust has definitely benefited from being late, essentially, or learning from the experiences of the past. And that's really validating. So you've got this public research. We've got this Google study. We've had other kind of language, other wider bits and pieces. And now internally you're validating that yourself. And you're not you are then able to demonstrate that not just the language is okay, but it would work well inside the build system or inside the context of the rest of the environment inside the company.
Yeah. There was one thing that the experience pointed to that was bad for Rust, okay? Because they gave out of how many stars? 4 out of 5 stars. Everything's great, hunky-dory. But when you get to the C++ interop, that was where it was like, that's a problem. And so what we used was C bindgen. So essentially you're writing the C functions in Rust, right? But that you can call from C, and that'll generate a header, which will call those C functions. And then the implementation of those functions will call your underlying Rust code. And this involves a lot of unsafe. It also involves a lot of C-ism stuff that C++ people aren't familiar with, right? If you go back in the day when you were writing C callbacks, you have a callback function pointer that you pass in, but you also have to pass in a void star for the context of that callback. And that's just like this idiom that you do in C to do callbacks. But if you want to have a interop layer in C, you have to do this and you have to understand it. And so what we found is that when you take somebody who's like C++, expert or very familiar with the language, and the first thing they need to do is go to the most gnarly, awful part of Rust, which is unsafe, weird stuff with pointers, like that experience is not good.
So let me paint the picture. So what we would like to do is basically pass objects around and their interfaces in some sort of ideal, essentially extend C++ or like bolt, either graft Rust onto C++ in some way, or graft C++ into Rust or whatever, so that a Rust programmer could just interact with methods from C++ as though they were essentially native. But we don't have anything like that because the two compilers don't know we don't know enough. They don't know enough about each other. You would need to teach Rust all of C++ in order for that to work in that way. Maybe I should also chat a little bit about this concept of passing function pointers around. For anyone although maybe you can correct me here, David, because I'm sure that this isn't technically precise. But essentially, the C++ and Rust worlds, they need to talk to each other through symbols in the binary. So the linker creates things, and all they really have is text strings to match on, or memory addresses. That void star is a memory address. And in C doesn't really have a strong type system. So you can basically say that any chunk of memory is any given type. So what you'll typically do is, if you're calling some external function or trying to call one of its functions, is get the symbol, resolve this, you ask the linker to resolve the memory address, what have you, and then call the function with a buffer that you have allocated, and then just hope that the function does what it says. And then you need to reinterpret your buffer as the result type. So essentially, this void star just means any type at all. How correct was that? Was that ish?
Yeah, that's generally correct. So when interfacing between C++ and Rust, if you want to do something higher level than C, right, you usually have a C intermediate layer. And the C intermediate layer, let's say you want to pass a C++ object over to Rust. Rust doesn't have an idea of what C++ objects are. So you get a void star, or you get a pointer, just an address in memory. And so when you want to call back into C++, you just pass that pointer back and hopefully it does the right thing. And then you do that. But it's not just for the object, it's for any argument, for any return type. All this is going through some like void stars under the hood. But ideally, you want to be better than what we did with that project, which is using like C bindgen. You want to have something which is richer and get this kind of interop working between C++ and Rust in a more seamless way. And so a lot of my work has been, how do we make this happen? And how do we get this to work? And I can go very deep into that subject if you're interested.
Hit me, because this is something that lots of people are thinking a lot about. And if you want to share, they would love to listen.
Sure. So to start out, the model of objects is very different between C++ and Rust. If you have a Rust object at some place in memory, you can always just copy the bytes from that place in memory to another place in memory, and that effectively moves the object. And the object is valid in this other spot. So if you do assignment in Rust, like A equals B, the way to think about it is basically taking the memory that where B was pointing to and make that the memory that A is pointing to, right? It's just moving the memory around. So in C++, that's not how things work in general. If you have an object, like let's say you have a std list, like a linked list or something along these lines. And the std list is implemented this way in many compilers.
Oh, there is another list. Because obviously in C++, we don't have one compiler. We have a standard, which is implemented by many vendors.
Yeah, and in this case, the standard library, the implementation of standard lists is different. Now, one one implementation that Microsoft has, I don't know if they still have it, but they had for years, is that the end node of the list is in the class itself, right? So you create a stud list, the end node's in the class itself. It doesn't have to allocate when you first create a stud list because it just has the start node pointer point to an object in the class itself. Now the problem is if you take the memory of a stud list and you just put it to a different location and say, okay, now the object's over there, that end node is now pointing back to where the original stud list was, right? So you don't actually have a well-defined object if you just copy the memory to somewhere else. The way that you move things in C++ is through a move constructor or a move assignment operator, where you by hand say how to create the object in the new location, which is equivalent to the old location. And that works totally fine with the stud list example because you just update that end node to the right spot. But this mismatch turns out to be a really big deal when you want to interact with Rust, because everything in Rust is you just copy the memory from one place to another. And if you put a C++ object in Rust and you just assign it to something else, now all of a sudden you catastrophically broke your object. And so that's like a major problem if you want to be able to talk about C++ objects when you're operating within Rust.
Wow. Yeah, no, that makes a lot of sense. And it's a pretty gnarly problem because you've got essentially two worldviews, and I was thinking, oh, couldn't you just overload the copy trait for particular bits and pieces? But then not really. No, that sounds tricky.
It's very tricky because Rust gives you this guarantee. A bunch of generic code is out there which will directly memcopy things around, and that's totally valid for every type that you give it. And so what do you do? So like the ways that people have been working around this issue, one is through pinning. So if you pin a type in Rust or an object in Rust, you're basically saying this object cannot move from this piece of memory. So assignment and all this kind of stuff just doesn't work with that, as you would expect, because it's just pinned in memory. And if you use a pinned interface, the drawback is it's very not ergonomic in Rust. It's like you work with a pinned object, you're just like, oh, great, now I'm going to have a bad day because this is just not friendly, good Rust code anymore. And so the CXX crate, which is one way to do C++ Rust interop, follows this method, and then you have to deal with that as a drawback. Another option, and this is what Zngur does. So Zngur, Zngur, it's not very well known yet. I'm trying to get more awareness to this C++ interop solution because it's very good in many ways. But anyway, Zngur, what they do is they say, okay, we'll just allocate every time we create a C++ object. So it always creates the C++ object on the heap. And that way, when things are assigned, you're just copying that pointer back and forth. But then you're paying a heap allocation, right? And that we lose our high performance there.
At least, yeah.
So
just, and this is probably obvious to most, but I'll just reiterate it for my own ignorance, perhaps. But memcopy is like ridiculously tricky, which are like single digit cycles time probably. Whereas, and so this is a millionth of a second in nanosecond scale, and then a heap allocation is anywhere 10 to 100 and 150, let's say. It's a lot of time if you're creating a lot of objects, or if you're just doing assignment a lot, like sort of updates, and you have to pay that cost every single time. That would be annoying.
Yeah, if I recall correctly, it's 1,000 times slower. So it's a substantial thing, especially if you get a vector of these things. Now you pay that for big O N.
Yeah, although references, I guess, which are just pointers really, can obviously, in the Rust world, we call this like the U size, or the size of the bits of the CPU architecture, they're instantaneous to copy around anyway. So this is one of the advantages of like plonking things on the heap. You amortize the cost of that allocation once, because you can now memcopy as many times as you require later on.
Yes. Yep. So there was a new feature that got added to C++ 26. We're in 25, so it hasn't come out yet, but it's in the latest C++ draft, called trivial relocatability. And what this does is it identifies the types in C++ to a rough approximation that can be mem-copied around. Because it turns out that std list example, like that's an outlier. Most things like a std vector, most classes that you would write, you could actually just move the memory to a new location and it would work okay. It's technically undefined behavior, but it works because that's just how it is. So the idea behind trivial relocatability was to see if there's a way to make this carve out of types that support this and make that defined behavior. And so the thought was, oh, okay, then maybe any type which is trivially relocatable in C++ 26, we can put this on the Rust stack and do stuff with it. If only
I
it
did
were that
note that
easy.
this was in the past tense.
The problem was there's a new architecture that Apple's coming out with. It's called ARM64E. And it's a security, an ABI change primarily created for security purposes. And what they did is if you have a polymorphic type in C++, so something that inherits from something with a virtual function, that needs to have a vtable in C++. In case you cast it to a base class, you need to point to the right function and so on. And so there's a pointer in every polymorphic object to the vtable, right? And this pointer is transparent to users. You don't actually see that it's there or whatever. Mem copying objects with a vtable is totally fine up until ARM64E. And what they did for security purposes is they said, look, the vtable pointer is a great way for hackers to own your process, because they can just take that pointer and point it to their own code. And next time you call a virtual function, you're going into the attacker's code. So they said, what we're going to do is we're going to take the vtable pointer and use some of the extra bits in it, because nobody actually has 2 to the 64 memory. So they're going to use these upper level bits and add some data in there that ties that vtable pointer to the object which contains the vtable pointer, right? So that way, if an attacker changes the vtable pointer to something else, if it tries to execute that vtable pointer, it'll be like, nope, can't do that. You lost the signature, which ties
So the
object.
CPU will essentially fault because I'm just going to use naive link. Maybe this isn't, but it sounds a lot like a capabilities model where the original, or some sort of provenance back to the original memory address, let's say, and if you change the destination, those parity bits won't work, and therefore, or some sort of checksum, and then, your program will crash, which is probably better than having some foreign code execute until you want to do something fun like interop with Rust.
Yep, exactly. And so in the C++ world, they solved this problem by saying, okay, instead of saying you can mem copy all these types to move them around, you can call this trivially relocate function, and that will do it for you. You trivially relocate, it does the mem copy, and it does all the vtable pointer fix-ups. And that's all fine and dandy in the C++ world. But now you go back to the Rust interop. Rust isn't going to do any vtable pointer fix-ups for you, right? It's literally copying the memory. And so that kind of broke that idea. And so what we're trying to do now is add a new feature to C++, and this is primarily for Rust interop. And what this will do is, instead of having the primitive copy thing from location A to location B and then do the vtable pointer fix-ups, it's going to get a pointer to where it used to live and a pointer to the current location and do the fix-up that way. So it's essentially separating the movement of the memory from the vtable pointer fix-ups. If you have that, then on the Rust side, if you get an object, and this is hard to explain in the podcast,
yeah.
I'll do my best.
It's not the best. It's not the universal medium, let's say. Like,
yes. You create your object on your C+ object on the Rust stack, but you add a little bit at the end, which is enough for a pointer. And so when you initially create the object, you have all your data for the object, and you have a pointer which just happens to be set to where that object's location is. Now on the Rust side, you can assign, you can move things around. Now the object is in some other location somewhere else. And that pointer is still set to the original place that object lived. The data for that object is the data that what it used to be, but it's just in a new location. Now, when you call a C+ function, you need to make sure this is all fixed up. So when you call your intermediate C layer, which eventually calls your C function, that intermediate C layer will call that special new function that got added to the standard, which says, hey, here's the pointer to the old location, here's the data at the new location. It'll fix up all the pointers for you, and now it's valid and defined behavior to call that C+ function that you were calling.
That sounds innovative. Well done. Have you unlocked the puzzle? Have you solved the puzzle, do you think? Or at least...
I think we may have. There are still some open questions on how to deal with this on the Rust side, because that works fine and dandy for C++ objects you create in Rust. But what if C++ gives you an object or a reference to one of those objects? Now that one doesn't have the little space at the end with the pointer. So that might be a different type. You might want to convert it to one with the pointer thing at the end. I don't know. There's some thought into how to deal with it. That seems like a decent enough chunk of the problem to be a good step forward. Because I presume that if I was importing a C+ library from Rust, most of the time I would be initializing the objects rather than essentially receiving an object that was created in the library itself. So, no, that's really interesting. How does a change like that happen? It must be, this is a little bit about how the committee works, but there must be years of deliberation for things like this to make progress. With the committee, there's a lot of formalisms and structure and all these kinds of things. People frequently get defeated by it because it's just like too overwhelming, too complicated. But if you understand it, there are tricks that you can do. So here's the trick that we're going to do. We're going to attempt. We'll see if it actually works. So right now, no new features are allowed for C++ 26, right? It's already been stamped. It's going out to the national bodies for ballot at this point. And now we deal with what's called national body comments. So every national body can say, okay, we released this, we got this spec, and we have a comment about this, a comment about this. And these are usually comments about bug fixes. You can never say add a new feature with a comment. And this is a new feature in C++ 26, this trivially relocatable thing. And so what I'm planning on doing is making a national body comment for the US, which says that we got our primitive wrong. The trivially relocate function is not actually the simplest way to express this primitive like basis operation for trivially relocatable types. It's this other thing, which is called start lifetime at. And through this bug fixing process, I'm hopeful we'll be able to say, oh yeah, that was a mistake. And so before C++ 26 ships, we're going to have this new basis operation, and that will unlock this Rust interop thing, but it also solves another problem that people had with the feature, which was that it didn't work with realloc, where you basically have an existing buffer that you're expanding, and sometimes it can expand at the same place. So I'm hopeful that we can get this to happen. But yeah, we're using this national body comment process to slip it in. Otherwise, we're going to have to wait for C++ 29.
I'm curious. I'll watch. I think it'll be fascinating because there's almost a meta discussion as well. But the committee processes are challenging. A lot of people don't really have stamina because everyone is so emotionally involved, because they wouldn't be there if they didn't think that things could move forward or improve. And they've got this great idea that they've been working on for years. They have a working implementation before they even start proposing it. And now you're telling me I gotta wait. Like, I gotta get it. I can just imagine that if I was doing this out of love or something, that there's no way I would be able to last 5 to 10 years to get new things through. I was looking at one time, I think it was concepts, how there were multiple implementations and different ideas about the way that could work. But then again, for something as impactful as making a change to one of the most fundamental programming languages in the world, maybe waiting 5 years isn't very long. Like, I mean, C++ is everywhere. And so it's extremely fundamental and it's extremely important. The stakes are very, very high. And so it makes sense to take things slow.
I think so. And I think that's one of its particular charisms, is that it is generally a slow moving language, not as slow as C, although C is speeding up, but you only can take on so much new stuff at a time. And I think actually, in my opinion, C+ has grown too fast for its own good. We've hit some kind of tipping point to where the complexity is more of a problem than it was a solution. And I don't know how to reverse that.
I think maybe human bias or something, but it's much easier to add an extra feature, like an extra box to the checklist or like the feature list. But taking things away is much harder. Just imagine saying, well, actually, we'll cut that out, is essentially impossible. More generally than C++, but it's like any sort of product, for example. Software products in general, I think have this tendency to grow until they collapse under their own weight.
Yeah, I think so. Also, if you look at it from like a company perspective, let's say you've got a huge code base. I think the last quote I got from Photoshop was like 79 million lines of code, right? So we're talking a lot of code. And somebody from a standardization body says, hey, you need to change 1 million lines of your code because we found a better way to do something. And the response is, does that add any value to my product?
Do the customers care?
Okay.
No, not really. Yeah.
Okay, so somebody up in the ivory tower has decided there's a better way to do something, and now I have to pay a buttload of money for this not going to actually have any tangible benefit? Nah. Rather, keep the existing code. You want to do something new with the new code we write? Great. But like that old code, if it's working and it's doing its job, like, please don't make me have to do anything with it, because the scale is too big. It's just way too much.
Are there any lessons for individuals that you think, who are navigating while we've talked about Rust language, C++ language, companies, but what about people and their own careers?
Yeah, I think that's a really good question. I think I can speak in particular for C++ developers. For someone who's a C++ developer, they're an expert in it, they feel very powerful in that language. And the idea of going to any other language, you feel very weakened, right? Because you're just so used to this language. If you're a C++ developer, you have a choice, right? You will definitely, no matter what stage of your career, be able to program C++ for the rest of your career. It's not going away. Those jobs are going to be there, but it will be with a legacy language, right? Especially towards the end of your career. It's going to be like, there are some Fortran people today and they do their thing. There are some COBOL people. I don't think it'll be that bad in 20 years, but it'll be in that space, right? But just be okay with that if that's what you want to do. If you want to be where the innovation is happening, then you're going to have to take a different approach, and you're going to have to look at things like Rust, and Rust in particular right now, I think is really important to look at. And don't be threatened by it. See, something that's not talked about a lot is that Rust is an outgrowth of C++. C++ is almost its granddaddy. People hate it when I say that, but it's true. So many lessons that were learned from C++ were incorporated in Rust, whether it's acknowledged or not. It's just obvious in the design. And if you look at it like that, you can be proud of it, right? You're C++. Look at all the stuff that they learned from C++. That's great. All the stuff that I did to help grow C++ or build C++ knowledge in the community of people that I'm with, this is a consequence of that. It's a benefit of it. And if you look at it like that, it's not as threatening. It's not like an us versus them. It's more like, good for them. Like, let me look into this, because this is the next step in C++'s growth is actually Rust. You wouldn't say next step in C++'s growth, but next step in growth for a systems engineer is using the latest tech. And the same is true for AI, right? It's like another one of these things it's going to be here, right? You're not going to change it and make it go away, but you can be part of the future and what it's going to bring. And so I would recommend to people to be open-minded about it. Check it out. Try it in a real project. You want to seek that feeling that so many people report that, oh, I went and I used Rust and I really don't want to use C+ anymore after that. You want to seek that experience, right? Because then you can get it and you can see where they're coming from and then see where that takes you. But you got to be open-minded, right? It's just you're going to have to try out some things and get past some biases and just say like, all right, I'm going to give it a whirl.
I think of Rust as a bit of a spiritual successor to C++. The one funny thing actually is, and Rust has learned so much from systems programming experience over several decades. And it's as though we have taken the lessons around initialization and destruction and just encoded that in the type system or into the compiler. There is this liberating feeling knowing that you're never going to need to worry about, I don't know, deleting an object twice. It's just, oh, that's not a concern that I need to have. Perhaps, but another thing is maybe they front load the concern because your design needs to be correct. But also, isn't it so much better that you get told that there's a problem early before you get told by your users that there's a problem, or worse, they don't tell you because they don't know and they've got introduced some sort of horrendous bug. By the way, that a lot of that stuff around C++ was accidental. I am not going to be able to find the reference, but Graydon Hoare was talking, I think it might have been on Twitter, or saying that was not the original intent with Rust. The original intent was something much more closer to Go, where or like a much more, with a much greater focus on concurrency. But then when it was adopted by Mozilla, the Firefox group really wanted to essentially be zero-cost abstractions all the way down and had this very heavy practical focus on being as lean at runtime as possible. Because if Rust was to ever compete, it needed to shed its runtime, which it had at very pre-1.0, like it's now over a decade ago. But it's a slight accident of history, but also really positive that the language was incubated in production. The idea that we were creating a programming language to be able to work in the context of a C+ program to enable multi-core. And that was a multi-million lines of code base built by many teams. And so all of those features were like part of how it grew up out of a hobby project originally. I think it would be like, this has just been such a really nice arc all the way. And thank you so much for sharing your thoughts. Has there been anything else that's popped into your mind as we've been chatting that you're like, oh, I should tell people about that?
I guess probably the biggest thing is check out Zngur for doing C+ interop. It's way less known than it deserves as a C+ interop layer, like very interesting. That's probably the biggest thing that comes to mind.
Okay, fantastic. I am so looking forward to your talk in New Zealand next month. I feel so incredibly honored that you have decided, that you accepted our offer to come down here. And I hope that you have a very enjoyable experience in the country. Until then, I hope that you also actually enjoy the process of preparing for a talk. I know that you'll have a very receptive audience. So thank you both for sharing your time and sharing your expertise. So thanks, David.
Oh, thank you so much. I am so psyched about the conference. So I can't wait to be there.